All right. So, guys, today we're going to talk about indirect proofs. Um, now, indirect reasoning, like legit, you're going to have to pay attention. Indirect reasoning, guys, is reasoning that assumes the conclusion is false and then shows that that assumption leads to a contradiction of the hypothesis or some other accepted fact, such as a postulate, theorem, corollary, definition. Then, since the assumption has been proven false, the conclusion must be true. Now, I'm going to say that again, and you're going to need to pay attention, because if I leave this to your own devices, you're going to fail. All right. Now, indirect reasoning, guys. You've all used indirect reasoning in your life, okay? Probably, or at least heard of it. So I'm making up this story completely, but it's just an example of indirect reasoning. Several of us are in a car, and and this guy or girl or whoever is giving us directions to this outdoor concert. All right. He tells us the last turn, we pull in, the parking lot's empty. All right. And that person is sitting there going, no, I know the concert is here tonight. And they just insist that the concert was there tonight. So instead of taking one arguing tactic, you take the indirect reasoning tactic. That's when you're like, okay, let's say that the concert is here tonight. If it were here tonight, what would we see? The parking lot would be full. You would probably see some kind of stage. You would see all this evidence. But here we are in an empty parking lot. So since that goes against what we would see, what we know we would see if the concert was here tonight, that leads to the fact that the concert is not here tonight. That is indirect reasoning. All right. Indirect reasoning is saying, when you say, you know what, let's assume that you're right. If you were right, then this would happen. And that means this. And that means this. But look around. That's not what's happening. Which means you can't be right. That is indirect reasoning. Okay. That is the simplest way I can describe that. Now, in geometry, indirect reasoning, I'm going to show you several different types. I just wanted to make sure that I wasn't showing you, like the ones in my head, I was making sure that I was not showing you examples of ones I was going to assign you in the book, because honest to goodness, there's not that many easy indirect proofs. Geometry indirect proofs are almost, for the most part, you'll see them when, for instance, lots of times, the easiest ones for me to think of are like, I'm going to show you for the exterior angle theorem or exterior angle inequality. All right. Inequalities are really hard to prove unless you prove it indirectly, because inequalities are not absolute. Like if I said X is greater than 2, then I am literally saying that every number, the answer could be any number that's above 2. So to disprove that, I would either have to, like, obviously this is just a piece of a problem. To disprove this by direct means, I would have to use every number there is, which is impossible, to disprove that. So you can't argue an inequality head on. You have to prove that it's impossible for it to be the other thing. So it has to be that, because there's so many options on what is a possible solution to this, means you can never go through and disprove them all. Now, if it was something like an equation, like where I had something like x plus 2 equals 4, it's very easy, and you tried to argue that x would be 3, it's very easy to disprove that, because there is one answer. And once you disprove that that's not that one answer, you're done. So a direct proof on something like that would be super easy. But when you're doing an inequality where the answer is literally infinity above 2, there's no way you can disprove all those. So that's when an indirect proof is by far not only your easiest route, but in that case, your only route. So, guys, the biggest thing that indirect proof. So hopefully you can sort of wrap your head around what an indirect proof is now. All right, you're basically going to just that sounds awful. That's a terrible analogy. God, I need to think of another analogy. Okay, yeah, I just can't. I'm not going to say that. Yeah, it's like you're playing along. Well, so I'm going to say it this way instead of using the analogy to keep talking. It's like you're playing along and humoring someone, and go with what they're thinking until they run into a wall, and they realize that, oops, my thinking can't be correct because now I've hit an absolute truth. I can't go against an absolute truth because it is an absolute truth. So you let somebody go along with their incorrect thinking and play the scenario out until they hit that point where they're like, oh, but that can't happen. And then once that happens, then you sit there and say, do you see how you can't be right? You see what I'm saying? So that is indirect thinking. It's like you're playing along. And you say, you know what? Let's go with this. Let's pretend you're right, and let's see where it takes us. And then it takes you down a road that cannot be, and you're like, okay, your way did not work, which means you are not right. That is indirect reasoning. Okay, it's very useful, especially when you want to prove somebody. I mean, because lots of times I can tell a kid they're wrong all day, and they don't believe it until they get to the point where they realize they're wrong. And then all of a sudden it's like, oh, I'm wrong. I'm like, I've been saying that. So it's sort of leading them to their own conclusion of saying, well, let's play out what you think and see how it goes. Okay. Now, number one part people mess up on indirect reasoning. Okay. An indirect reasoning or an indirect proof is a proof by contradiction. Like I said, you play it out, you let them see where it takes them. It takes them into a dead end because what they're doing can't be done. And then they're like, oh, crap, I'm wrong. All right. So that's what it means by proof by contradiction. You've basically argued yourself into an impossible win. You can't do it. Now, number one, guys, step number one is the most missed thing. And that's sad because you can put a lot of effort into steps 2 and 3. But when you screw up on the first step, not much place to go. Y'all, on any proof, whether it's direct or indirect, you are always given a given, right? And then you are always given something you're trying to prove, your conclusion. Everybody remember that. Guys, what you're given cannot be changed. Okay? What you're given cannot be changed. That's the air purifier. So yeah, Van was looking like we were under attack. He started to get real nervous. So number one mistake that people make is they try to change the given. Guys, I gave you this. You can't mess what was already given to you. You can only mess with what the conclusion was, what somebody draws from the given. Okay, so the number one thing people mess up on is instead of assuming the conclusion is false, they try to change the given and make it false. And I'm like, you cannot mess with the given. The given is given. Okay, I mean, you might want to write that down. I don't know. The number one thing people mess up on is step 1, which means step 2 and 3. I mean, makes it real easy for me to check because I'm like, well, that's wrong. But step 1, you never mess with the given. The given is given. You only take the conclusion and assume the opposite of it. Okay? So if I gave you, I don't know, crap. If I gave you something like, I'm literally making this up. So the sky is blue,
False.
and if the sky is blue, the sun is out. Okay? Okay, I'll say the sky is clear. How about that? The sky is clear, the sun is out. All right? Now,
If it's nighttime,
then that is false.
then false. I said it's false.
Oh, I thought you said that's not false.
I said that is not true.
Okay. All right, now, boys and girls, listen. Like I said, number one mistake when somebody is trying to disprove this is they'll say, assume the sky is not clear. And I'm like, great, you've screwed up. You can stop. You're wrong. Okay? What you would assume is, let's say the sun is not out. Okay? That is how you would start this proof. Whatever the conclusion is, that is what you attack, not the given. The conclusion is what you attack. Only the conclusion, because you can't change the given. Now, guys, so like I said, that was complete crap. I just wanted to show you are not going to ever mess with the given. You only mess with the proof, boys. Now, once you've done that, then you're going to show that assumption that you made leads to a contradiction of what you were given. All right? It leads to a contradiction of normally of what you were given. Sometimes it could just be a random fact that you know can't be possible. And then you say, since that can't be, the only other option is this. All right? Now, and I get that that's confusing to wrap your head around. So we're going to start off nice and easy. All right? I want you to state the assumption that you would make to start an indirect proof of each statement.
Were these like conclusions?
Yeah, I didn't give you a given in any of these.
Okay.
Okay, so boys and girls, you are going to keep this simple. All right, you are going to keep this simple. We are not going to be specific. All I need to do is, just keep it simple. All right, so the number 117 is divisible by 13. You would say the number 117 is not divisible by 13. To start it off, you are going to assume the conclusion is false. You are not going to tell me what. Okay. So I don't care. You're not going to come at me with Boris as the worst candidate. I don't care. I just want to know that he's not the best. Okay. So be careful. Don't try to be specific. Don't try to do polar opposite. It's not about polar opposites. It's just about not what they're saying. All right. So just be careful with that. Now
So AB is not the union
right.
of ACD.
All right. Letter C, AB is not a median of triangle ACD. Now, guys, On D, I need everybody to pay attention to D. As far as right, but I want you to pay attention. So most people would say something about measure of angle C is not greater than the measure of angle D. This is useless in a proof. Okay. What if you were actually proving this, which I'm going to show you something with this. For me to say that in a proof, I mean, this is technically correct, but as far as in a proof goes, I'm going to show you. You would have to, well, I'll get there when I get there. But so basically, you're just saying not. Very simple. Okay. Now, yes.
It's kind of like you're starting an argument. Like,
Right.
someone says something.
Like whenever someone says something, you just keep saying no to it.
No, well.
All right. Do I want to start off simple?
Yes.
All right, we're going to start off simple. We will. We'll start off algebra instead of geometry.
So what should we say?
That's kind of messing my brain.
I'll show you because I'm going to do one.
I just understand not to put it.
Okay, so let's say that I am given, we're going to start off nice and easy with an algebra proof. All right, so let's say negative 3x plus 4 is greater than 16. So I give you an inequality. And you are to prove that x is less than negative 4. Now, guys, once again, because it's an inequality, you can't go through and cover every positive number to show that it's not a solution, or like everything bigger than negative 4 to show that it's not a solution. You can't. You will die before you finish. And you can't cover that and prove that everything less than negative 4 is a solution. Once again, you'll die before you finish. You cannot do it like that. All right. All right. Did you just hear him yell?
Yes.
Okay.
What would you say?
No.
Everybody right now.
No, that was not a laughing yell. Okay. Now, guys, you're gonna start off. Write the first beginning to this proof. All right, guys, I'll give you a hint. The beginning of this proof is going to say, all right, well, the beginning will say proof, but duh. Assume. Assume, because you want to make a donkey out of the person. So you're going to go ahead and say, let's assume you're right. All right. So hopefully you said in your head that you're going to assume, and you would not have to write all this out. I'm just writing it the first time to show you where it's coming from. So you would assume that x is not less than negative 4, which you don't have to write that part because, like I said, it's not really going to help you. Meaning, what does that mean? If x is not less than negative 4, that means that x is greater than negative 4 or x is equal to negative 4. See, here's the thing. You have to disprove both cases. Okay? So, and the equal to, I mean, it's all pretty easy. You have to disprove both cases. So, on an algebra proof, something like this, it's very simple to disprove this. All right? So basically, we are going to make a table. Okay. we are going to cheat to make a table because I already know I cannot draw a straight line.
That's a good straight line.
Thank you. I worked real hard on it.
It's another way to do it.
Baby, yes, this is, of course, is another way to do proofs. This is what we're doing, proofs. Okay, boys and girls, I need you to think of the objective. Yeah, you're not focused at all. I need you to think, it's okay because this is really easy. I need you to think of the objective. All right. What are we trying to we've assumed that x is greater than -4 or x equals -4. So what do I need to choose as my x's?
Something greater than -4 and -4.
Good job. So I need to pick -4. I need to pick like -3, -2, -1, 0. Okay. Obviously you could keep on going, but your evidence, that's enough evidence. Should be. All right. Then you plug them in. The algebra ones are super simple. So that would be what? -12. So that'd be -8. -9 plus 4 is -5. No, I did that wrong. That's wrong. No, -3 times -4 is +12. That's 16. Sorry. That's 9. 9 plus 4 is 13. There we go. That's 6. 6 plus 4 is 10. All right. That's going to be 7. And that's going to be 4. All right. So, guys, based on our proof, and the proof is math facts. All right. When x is equal to -4, all right. So I said, and I'm lazy. You can do this too. I'm not writing that out twice. So when x was equal to -4, your answer was not greater than greater than 16, like it was given. That's the fact that you were given. Okay. That's what you had to work with. So this goes against that given. When x is greater than -4, the answers, that would be the only change, is I'd say the answers instead of the answer are, well, I'd say are as well. The answers are not greater than 16. All right. Then you would say, and this you're pretty much going to say every time, something of this sort, which is why I'm going to type it. All right. You would say, in both cases, I want to say data. No. The assumption leads to a contradiction of the given. Is that how you spell contradiction? No. That's contradiction. There we go. Contra. Wow, I fixed it. Contradiction of what was given. Therefore, the assumption is false.
You just go along with it until it proves like until it doesn't go with
Till it contradicts itself and says, well, that can't be. All right.
Only question is, how do you know they only got any?
All right. I just chose. You can just pick, like, I just picked a couple of numbers. Now, guys, so you're almost always going to end it in saying, you know, the assumption leads to a contradiction of what was given. Therefore, the assumption is false, meaning that what I'm trying to prove must be true. Algebra ones are super easy.
Can we do those first?
We will, yeah.
Thank you.
Now, if I did a geometry one, we're about to watch this loveliness.
Where's not the video? We can see algebra ones. They're awesome.
yeah.
Yep. I'll prove that the measure of angle 4 measure angle 1. All right, so all right, so boys and girls, so if I give you that angle 4 is an exterior angle of the triangle, and I want you to prove that the measure of angle 4 is greater than the measure of angle 1 and greater of the measure of angle 2. Well, the good news is you only have to do one of them, because you would say for the second one, you would say measure of angle 2 is just like same circumstances as measure angle 1, therefore look above, kind of thing. So really you're only focusing on one of them. So let's just focus on the first one, because it's going to be the same with the second one. So we're going to assume what?
The measure of angle 4 is less than the measure of angle 1.
All right, so we have to assume two things. Is less than the measure of angle 1. So this So we have to disprove that it is less than or equal to. Okay? Now, case 1. And it doesn't matter which one you start with. All right? Let's tackle the easier one. Measure of angle 4 is equal to the measure of angle 1. Okay? Now, let's say So what do we know about this? How would we disprove this? Y'all know about the exterior angle theorem, right? So what does the exterior angle theorem say?
Measure of angle 1, measure of angle 2 equals.
Good. So that's not by. Good Lord, that's B. Sorry. By the exterior angle theorem. By the exterior angle theorem, the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. Everybody good with that? Now, if measure of angle 4 equaled the measure of angle 1, I could substitute. And get this. If I substituted, I could say the measure of angle 4 equals the measure of angle 4 plus the measure of angle 2. Then I could subtract the measure of angle 4 from both sides. And get, what would I get once I subtracted measure of angle 4 from both sides?
Measure of angle 4 equals measure of angle 2.
Nope.
No.
0.
0 equals measure of angle 2. But, and this is where we come in. But we know now, guys, this is a proof where we're not leading to contradiction of the given. We're doing contradiction based on a fact. But we know angle measures can't be 0. And instead of writing therefore, just so you know, okay, I need you to go away. Okay, for real?
Oh, Rizzo.
Okay, that's when those 3 dots, because you get tired of writing therefore, that means therefore the measure of angle 4 cannot equal the measure of angle 1, because that would make measure of angle 2 equal to 0, and that's not possible for an angle to be 0. Okay, so that takes care of case 1. All right, I'm going to change colors, and case 2 is going to be sort of similar. All right, so case 2, we're going to attack it the same way, guys. So case 2 was saying that the measure of angle 4 is less than the measure of angle 1. Okay? Now, once again, you're going to start off by the exterior angle theorem. By the exterior angle theorem, we know that the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. right? Now, guys, why can't this work?
Because we already know that.
Measure of angle 2 equals 0.
If the measure of angle 4 was less than the measure of angle 1, okay,
Measure of angle 4.
y'all, what do all angle measures have to be? Rocks, churches, equal 180. No, all angles don't have to be 180. All angles don't have to be equal. But what? There you go. All angles have to be positive. If this were the truth, this angle would be negative, which cannot happen. Okay? So because we know angles have to be positive,
Does it tell us how much 4 is?
it doesn't matter.
Well, like, 1 could be less than 4.
No, it can't, because 4 is an exterior angle.
No, 1 and 2.
No, 1 is less than 4.
Yes.
No, sorry.
Like, so that's that. So,
But 1 and 2 combined makes
So
4.
2 is just more than 1 and 4. And 4 is more than 1.
no, because if 2 is more than both of them, then it would be equal. Because then
Well, no matter what, 4 is greater than 1.
no, if the measure.
Oh, it's saying that 4 is less than 1. That's what it's
No,
saying.
it's saying that the measurement in 4 is equal to measurement
No, like-
plus measurement.
I know, I'm saying, I thought it was saying 4 is greater than 1. So I was like, that's how it works. But no. Because if it was less than 1, then 1 would have to. That can't work out. So yes, therefore your theory is correct.
Okay, so if you look at this, by the exterior angle theorem, measure of angle 4 equals measure of angle 1 plus measure of angle 2. Because of the simple fact that we know angles have to be positive, measure of angle 4 can't be less than, because then you would have a negative angle measure, which means angle 4 cannot be less than the measure of angle 1. And then once again, you would end it with, in both cases, the assumptions led to a contradiction of facts. Therefore, what we were trying to prove is true. I just don't have room to write it. So once again, you would literally say, let me just copy and paste this. You would say, in both cases, the contradiction leads to a contradiction of what was instead of what was given. You would say a fact, because it's a fact that angles can't be 0, and it's a fact that angles can't be negative. All right. Therefore, the assumption is false, meaning whatever we were trying to prove, x, the measure of angle 4 is greater than the measure of angle 1, is true. Quit it. And then, so you would say, meaning measure of angle 4 is greater than measure of angle 1 must be true. And then you would say, you would literally say, same thing for measure of angle 2. And that would be it for that. Now, guys, proofs by contradiction are hard to do. So yeah. Now, this is what I want you to practice. You are going to do
460.
okay. I want everybody to just think with me. Okay, we're gonna do it this way. I want everybody to think with me. That's not how you spell that. That's still not how you spell that. Good Lord.
Hypo?
It's L-E.
Ah!
Hypo?
Okay, if I were given a right triangle, okay, once again, I don't mess with the given anyway. If I wanted to prove that the hypotenuse was the longest side of a right triangle, you don't have to write this down. I just want you to think. Like, honest to goodness, some of you are not thinking. Jacob, you're not thinking. I want you to focus and I want you to think because you can't do this on your own yet. Okay? Now, I need everybody to be able to say, what are you going to assume? Just think for a second. It's not on your phone, I can tell you that.
Oh.
It's all right. I don't care if he fails. All right. So who can tell me what I'm going to assume? Brucey?
The hypotenuse of the longest side of the hypotenuse is not the longest side.
Okay, so your assumption, guys. I'm not even going to spell it. All right, guys. All right. Hush. Nobody likes y'all right now. All right. Giving me grief about this. Okay. It's not true. I love you. Okay. So, guys, we're assuming the hypotenuse is not the longest side of the right triangle. Think. What does this go against?
Every single law of nature.
Shh. Nobody say anything. I got one kid getting it. I want you to think. Don't say anything. What fact does this go against? I'll give you a hint. We dealt with it yesterday. Got 2 light bulbs. That's nice. I got a semi-light bulb.
Is that me?
No, Izzy keeps doing this and trying to flip her page to find her fact.
I'm pretty sure I got it.
Who would it break down?
I don't write anything. I store
Bush, what goes against this?
Okay. You have the biggest angle, and the side across from it is the longest side.
The 90-degree angle is the largest angle in a triangle, and that means that the longest side has to be opposite. What is the side opposite a right angle? A hypotenuse. That means that it can't be anything. It has to be the longest side. That is how you would indirectly prove that. You look for a fact to help you say, oh, wait, no, it's a fact that the largest angle has the largest opposite side. 90 degrees is the largest angle in any right triangle. The opposite side is always the hypotenuse, which means that it can't not be the longest side. That is the indirect proof. Okay? That is how you have to think. If 2 angles are supplementary, you know what? I'm going to make you do that one on your own. I want you to try 1 through 6 on page 388. And then number 10. Guys, just so you know, 1 through 4, all you're doing is making the first right assumption. So that shouldn't take you long.